72% of operational failures begin with local optimization. Departments improve their own metrics, but the overall system becomes weaker. This is one of the biggest hidden problems inside large organizations. And Boeing is one of the clearest examples of it. Engineering optimized for development speed. Procurement optimized for supplier cost. Operations optimized for production targets. Program teams optimized for delivery schedules. Each department improved local performance, but system-wide risk increased. This is called local optimization. Local optimization happens when departments improve their own efficiency without understanding downstream impact. And over time, organizational friction starts accumulating. One of the easiest ways to understand this is through SIPOC. SIPOC stands for suppliers, inputs, process, outputs, customers. SIPOC helps visualize how work flows across an operational system, because organizations do not operate as isolated departments. They operate through connected processes. Now, let's apply SIPOC thinking to Boeing. Suppliers provided aircraft components. Inputs included engineering specifications, manufacturing systems, compliance requirements, and delivery schedules. The process included assembly, integration, testing, quality checks, and approvals. Outputs were completed aircraft. Customers included airlines, regulators, and passengers. Now here's where the operational problem started. Procurement teams focused heavily on supplier cost optimization. That improved procurement metrics. But supplier dependency complexity increased. And dependency complexity creates coordination risk. This is where dependency mapping becomes important. Dependency mapping helps organizations identify where teams, suppliers, approvals, and processes rely on each other. The more dependencies a system has, the more communication quality matters. The more escalation systems matter. The more governance matters. And the more operational visibility matters. Because delays rarely begin inside isolated tasks. Delays emerge at handoffs between teams. Now, let's connect this to KPI conflicts. A procurement team can successfully reduce supplier cost, but lower-cost suppliers may increase quality variation. Quality variation creates rework. Rework increases delays. Delays increase schedule pressure. Schedule pressure increases operational risk. And suddenly the organization starts solving problems created by disconnected optimization. This is one of the biggest reasons operational excellence requires systems thinking. Improving one department does not guarantee improving the organization. Now, let's look at flow efficiency. Flow efficiency measures how smoothly work moves through the overall process, not how busy individual teams appear. This distinction is critical. A department operating at maximum utilization can actually reduce total organizational throughput, because overloaded systems create queues, and queues create delays. This concept is heavily connected to the theory of constraints. The theory of constraints explains that system performance is usually limited by bottlenecks. Improving non-bottleneck areas creates very little organizational improvement. And in some situations, local optimization can actually increase pressure on bottlenecks. Now, let's connect this back to Boeing. Supplier complexity increased. Coordination complexity increased. Dependency chains increased. But visibility across the entire system became harder. And this created another major operational problem. Reporting started replacing operational understanding. Dashboards can look healthy while hidden risks accumulate underneath the process. This is why process mapping matters. Process maps help organizations identify handoffs, queues, rework, ownership confusion, approval delays, and bottlenecks, because operational friction is usually hidden inside process transitions, not inside isolated activities. Now let's look at governance. Good governance is not bureaucracy. Its purpose is alignment. Governance ensures departments optimize for organizational outcomes instead of isolated departmental metrics. Without governance alignment, organizations naturally drift towards silo behavior. And silo behavior is where local optimization becomes dangerous. Here are 5 operational warning signs of local optimization. Number 1. Departments hit KPIs while customer satisfaction drops. Number 2. Utilization increases while delivery speed slows down. Number 3. Teams appear busy while cycle times expand. Number 4. Reporting volume increases while visibility decreases. Number 5. Escalations increase between departments. These are system-level warning signs. and they appear in organizations long before visible failure happens. This is one of the biggest lessons operational professionals can learn from Boeing. Large failures rarely begin with one catastrophic mistake. They begin with disconnected optimization across the system. And over time, the organization becomes harder to coordinate, harder to stabilize, and harder to manage operationally. That is why operational excellence requires system-level thinking, not isolated efficiency, not departmental optimization, system optimization. If you found this useful, subscribe for more operational excellence, PMP, Lean, and Six Sigma breakdowns. And follow me on LinkedIn for visual frameworks, process improvement concepts, and operational case studies.